Hey everyone, welcome to another live noding session with Blender Sushi here. Today I will be covering a topic like an old topic that I tried to do a few times in the past. Um, I did try this kind of explore this area using PyDriver and Python, and I will attempt to do that again using animation nodes because it's kind of interesting area, and I found it makes more sense like this. So it will be something to do with this pixel art. This is from Super Mario Bros. And the actual image I found from internet is like 400 by 400 pixels, but we actually just need the mushroom pixel. So it's kind of maybe it's around 16 or 32 by 32 pixel. We will resample this image using animation nodes and some Blender techniques. It's not 100% Python, not 100% animation nodes, but we will use some Blender features. I want to also point out this wooden mirror by Wenya Chen. It's from 1999, and I can't believe how old, how it must be really cool to see this kind of effects back then. It's kind of like a wooden, kind of like an installation. It's like a wooden mirror, so it looks like maybe there's like a webcam, and it looks at the person, and the mirror will kind of reflect that. It's probably sampling the image. It's probably like maybe 60 by 60 or something pixels. It's not that high res, but it's the effect is quite interesting. Um, yeah, it's there's animated GIF that's showing the effects. Where was it? There you go. So I kind of like this effect, and I tried to do that using Blender. I always like this idea of kind of having like a real-time input and then convert that data into like a real-time feedback kind of thing. I realized that Blender or any 3D package is probably not the right answers for what I'm trying to do. Sometimes it's not always real time, especially with 3D software. Maybe using Blender game engine I could achieve such effect, but things like maybe processing or OpenCV or maybe like shader toy here, like I was told by Dealga McArrow here by Zevi. Yeah, shader toy can do real-time kind of effects, but shader toy using kind of OpenGL kind of shader programming, it gets really complex, even though probably the basic idea is simple for programmers. My background is not really programmer. I'm more like an artist, but I like some technical stuff. And yeah, I've been writing back a few years ago. I was writing this effect. I mean, writing this blog article about how we can do like a pointillism by sampling image in Blender. Yeah, it's kind of interesting. So there are two things. The first one is kind of how do we can convert this pixel art into 3D objects. Like there are a couple of ways, and I believe there are a few video tutorials from another Blender channel that's kind of showing how it can be done using cycles. I will be just using Blender internal render, and I'm trying to color each object kind of to match the pixel art. So just like object color, and then if we have the texture that's displaying object color, so I will kind of instance the objects, and then each of the objects will sample the source image. In this case, it's a pixel art. So I'll try to do it. Hopefully it will not take too long. So the first one is converting the image into a bunch of 3D objects, maybe arranged in the grid, and then each one of the objects need to sample this artwork. The second one is probably, I'll probably do this in the next video or a bit later, but this is the idea of like kind of stamping 3D image into 2D artwork like this, kind of like pointillism, but I'll use Blender to do that. You can probably do this using processing much easier, but with this kind of technique that I'm trying to show you, it will be less of programming but more of thinking. It's good to think like this way sometimes, so let's just do it. Quit Safari, so I have more memory. Okay, back to Blender, create a new default scene. What I will do here is actually, I will be using the modifier, displace modifier techniques. I did this a couple of times, but I haven't actually show you to do this kind of thing. So as we already know, if we have a mesh, and this is like 9 by 9, so it's like, no, it's actually like 10 by 10, 1 2 3 4 5 6 7 8 9, so 9 by 9 in the polygon, but it's 10 by 10 in vertices, so a total of 100 vertices. So this guy, if we use the displace modifier and we use an image like, so in our case it's the mushroom pixel art. Let me try quickly load it. Okay, this guy, which is actually 400 by 400 pixel. Okay, this guy, we can get like a real-time effects here, so it's not displaying too clearly, but I will just subdivide it, subdivision surface, put it above and increase it. So okay, apparently it's displaying, it's tiling the image by default, and that's because I don't actually have a UV on it. Single image, straight image sampling, image mapping, repeat, clip. Clip is actually probably better. Extend, clip, cube, repeat, checker. No, I'll deal with this later, but as you can see, we can have this kind of real-time effect, and Blender displace modifier is sampling the image. I think that's the fastest way to do it in Blender. So I'll show you also. If for the texture coordinates, we won't be relying on UV. We're just gonna rely on like object. Say we're gonna use the empty as our texture positioning. So it's gonna be like that. So the mushroom, so scale 1 by 1, it's gonna be like that. So that's pretty cool in itself. And as you can see, it's really fast, 400 by 400 pixel, and it's sampling the image, and then yeah, we get it real time. We can play around with it. And this kind of data, as it is not so cool, I guess. It's just pushing the pixel in that direction, up or down. Not very particularly interesting. But you know what? With things like animation nodes or maybe Sverchov or any kind of node base, we can create a setup where we can use this data in this kind of data we can use for other purpose and make things more cool. Okay, so let's try, and I'll start with a new Blender file. I'll go to compositing layout and let's play with animation nodes. So let's do it. Let's hide the lamp and the camera to layer 2. Okay, I did that. I always do that. Now next we're gonna switch to animation nodes and create a new node 3. We know that for this kind of project we're just gonna need a grid. So luckily we already have grid mesh. So the thing with animation nodes or any kind of node based workflow in computer graphics, if someone create a node for you to do something, then you're probably done with it, but that's not always gonna happen. Maybe there is like there's like a Voronoi node to create like a fracture, or like a Voronoi any kind of modifier that allows you to do like a cool stuff. That means you're pretty lucky as an artist, because things like Voronoi, if you make it yourself from scratch, is kind of super complex. But if you have it as a modifier, then it's done. You can just apply like a fracture or things like that. A single node that can do such complex things, it doesn't always happen. Sometimes of course, you need to create a setup yourself, right? That's obvious, but not always clear. So okay, I wish that animation nodes has like a sampling node, like just a single node that can sample image really fast, just like the Displace Modifier. But of course, in this case, I will use the Blender modifier because it does the job, and then you can use it inside animation nodes. Okay, so the grid mesh is going to be procedural instead of creating it on the scene. Okay, it's going to be, I'll start with 10 by 10. I guess that's a good start. So it's 100 points, and I will output it. Object mesh data. No, it's gonna be, you're gonna output it. So object output, and we're gonna combine it. Combine mesh data. And plug that in, and display it, and then create a target object. Now we can see our 100 points vertices, but we want it as, you can actually leave it like this. We don't need to create edges or polygon. I believe we can just leave it as vertices like that. I'll save it. It's gonna be AN pixel art convert. Just pixel art. Save blend file. So see 100 points, and we already have it in 3D, and we're gonna displace it. Use Displace Modifier, and as we know, this Displace Modifier, we will use it to sample an image. This texture coordinates gonna be the object, and we're gonna need an empty. Empty can be arrow. Okay, so this guy is empty. Let's see. What is that? Okay. And now jump into the texture. We're gonna source our mushroom image, 400 by 400. Open image. That's our mushroom art. Okay. And we don't need to change anything. Just leave everything as it is. What I'll do, perhaps simply, okay, it's actually in the modifier. The directions, instead of the point normal, we want it to be RGB to XYZ. So we can't really tell what's happening right now, but if I turn off the strength, well, for now I'll just guess the scaling should be probably around 5 or 2. It's kind of displaying the mushroom, sort of. Maybe if we have more, like 40 by 40, and close the empty and then scale it up. So you kind of see, you can see the mushroom already, and it's just a bunch of points. I think I'll reduce it back to 10 by 10. 10 by 10. Let's see if I can kind of guess if we can see the mushroom thing. I think that's about right. So it's 5 by 5 by 5, somewhat. That's the scale. And it's not displaying anything, so the next thing I will do is to kind of instance some cube, mass cube, and this cube is going to be our default cube. It needs to have material that can display object color, so I tick that. So that's the original. I can scale this down, but I'll leave it like that for now. Okay, I'll scale it. Okay, and then I will source this back into animation nodes. So this guy right here, just generate the mesh, and then this mesh we use the modifier to sample the image, etc. I will source it back into animation nodes. I could create a new node 3 for that. So this one, generate mesh. This might make everything faster. Create a new node 3, so this guy will convert to pixel. That guy, get the object mesh data, search that guy, and make sure we tick the use modifier. in fact we actually need two, and this guy doesn't use the modifier. And next thing I will do, I will instance this box into each and every points at the original position, so which is this guy. So hit W, loop through vertex locations. So this is the vector original. It's the original points positions. I'm gonna quickly create another one, another vector list. This one is vector displaced. Okay. And then we will need some object instancer. Object instancer. How many? We just plug this in. It will tell the length. The total number should be 100, and it's going to be sourcing our cube. And so we need to iterate over it. So we need object list. Let's plug that in. So object instancer. That's that one. Plug this in. That's the object list instance. Next, we're just gonna place our object. So we're gonna use object transform output. Object location will be vector original. Convert to pixel. Nothing seems to be working. Wonder why. I disconnect that. Okay, vector locations. Okay. With the points being deformed, we can just hide it. I'll put it into another layer, so we don't need to see that. And we have our instances. I will hide the relationship lines. That line, I will hide it. Tap U, hide relationship lines. Okay. Next thing is I will check the coloring. See if it works. Coloring doesn't work. We need to enable copy full objects. Okay. Okay, then the next thing is I'll just show you how we can use the displaced points and turn it back into RGB. So I'm gonna need the outliner. So that's our points being displayed. So this modifier is sampling image texture and turn it into XYZ and then pushing the points. Now in animation nodes, we're gonna turn the XYZ back into RGB. So it's gonna be almost like real time. It's pretty fast. Probably faster than using Python or around the same. But modifier is always fast. And so we have our vector displays. We're gonna use that value and turn it back into color, just like this guy. Of course, we already know we can just use attribute output, object attribute output, and we're gonna be modifying the color attribute of each object here, which is that one, object color. and it's kind of unique for every real object in Blender. Let's see if we can just plug that into this guy and then source the object color. It's complaining value has a wrong type. We need a better, we can use converter. In this case we need a 4 value. It's RGBA, red, green, blue and alpha for color. Mix float. So it's a this float. Let me think. Create float list. So with this guy we can have 4 floating value for RGBA. So vector being displayed. To display separate vector. Okay. Separate vector. Plug it in. RG XYZ back to RGB. And if we plug it in, it's still not gonna work. We need to have like a converter node, convert, and plug that right there, and then it knows in the color and plug that into there. So we have this happening. So it's not quite right. Wonder why. So maybe I forgot something, or maybe I did it in purpose, but the way to find out is to use the debug. Let's see, debug loop is perfect for this. So plug, we want to see the value. What is this really, the value that goes into the RGB? So it's the value seems to be too high, and it goes to minus. For Blender RGB needs a value between 0 and 1, so let's see if we can map it. Map range. Of course we have all the data already. That's a good thing to keep in mind. We just need to convert the data and take advantage of the data and make it useful for us. So it's gonna be looking at input min and max. Probably value seems super high, so I think I forgot something, but we need to subtract the vector displays with the original vector, because we just need the RGB value. Remember how we have our points in 3D space and then it's got push? The points itself, which is the vector value, already has value to position the points, and then it's then being displaced. We're gonna need just the displaced value vector, so we're gonna subtract it. So we need vector math. Vector math is gonna be subtract. So this is it's gonna be the displaced vector minus the original vector, and with the result, let's have a look. Now we have 0.50. So it's actually, we got the value right away, so it's minus 0.5. God. Yeah, that's actually, we don't need to map range somehow, which is perfect. That's actually pretty cool. Subtract, separate, So from the original image being sampled by Displace Modifier RGB to XYZ back to RGB. Yes. It's really cool. It's faster than I thought, and we are almost done. This have the blue value. We might need to just turn it into white, but don't worry about that. Maybe if I render it out, you can see it's let's use ambient occlusion. Oh, it's fine. It's not giving, it's not having the blue. So now I told you that the effect is almost like real time, and it does. Let's zero out our locator and then scale up. So this is 10 by 10. 10 by 10 is probably not correct. We might need a maybe 16 by 16. Let's go to our original grid mesh, turn it into 16 by 16, and then we increase the empty. Maybe this should be like 12. Now it's kind of, we are pretty much there. So it's the pixel art thing happening. The cube scale, I will just use my eyeball and scale it up. That's pretty close, so it's good. This is from that pixel art converted into 3D objects. Yeah, and then I will play around with what we got here right now. I will hide this original box cube. So we have these, and then let's jump back to convert to pixel. So no programming, just data being piped from one form into another. We can delete this debug loop because it might be slowing down a little bit. It's actually pretty fast. It's only like 6 milliseconds, and like this is almost like real time. What we can do next is probably, let's say, of course we have this control with object transform output. We can, of course we can scale, randomize the scale if you like, scale, randomize, randomize the locations. Yes, let's do that. So let's put this down there. We have this location, which is the grid. We can randomize it. Vector random. Oh, wiggle. Okay, we wiggle. Wiggle is cooler. Wiggle index plug into there. Evolution. Just use time. Frame. Plug that in, and we need vector math. This guy, okay, we don't need to actually, it looks like slow, right? But it's not, we actually don't need to calculate it all the time. If we switch it off and then turn off auto execution as well. maybe just for now. Okay, should be a little bit faster. So wiggle goes into wiggle, and the original grid position, plug it in, add it together, and you get this. It's kind of almost like particles. We are faking particle simulations like that. That's kind of like if you are using procedural, it's not a simulations. We are not dependent of time or anything. We don't need to bake the simulation. We have all the data there all the time. Sometimes this is kind of like ideal, I guess. You can't always have this setup. Sometimes with a scripting or simulations, you can have effects that's much more sophisticated, but it depends. Sometimes procedural workflow is you can have more control. So yeah, let's wiggle. It's wiggling our thing. So sometimes, you know, if let's say, okay, the cool thing you can do instead of box, because box is kind of too simple, to simulate that kind of like a mirror thing, we can say use a cylinder. So I'm using cylinder and leave it as at default size. It's 1 by 1 by 1 in dimension. Now if I go to our instancer here, object instancer, we can source this object. Now it's become cylinder. It's like coins there, and we lost the color, but we just need to reapply it. So it's cool. It's simple. The effect is real time, and we can always resize this guy. So the thickness of our coins and the scaling, let's just adjust it right here. This if you don't believe me, each object is actually respecting the object color, so that's cool. And with rotations, for example, we can use things like random Euler, and index goes to Z, Euler goes into the Euler, and we get something like that. So it's kind of, it looks like complex, but it's actually super simple. If you follow all my videos and blog posts, this example is actually super simple. Yes, so we have the mushroom thing, but it looks much more complex and cooler than just being displaced. Just we can play around with this with the numbering. In fact, since we're here, we can actually, instead of having like a random Euler, we can have the effect just like the mirror thing. So let me zero out that, and then with the scale I'll make it like yeah, something like that. 0.1 for the thickness. I'll save this. So instead of having this colorful artwork, we just gonna matte cap it and using gold. So it's gonna be, it looks like just flat, of course, but we can use let me zoom out, zoom in, and then let's just use the vector distance, and we are comparing this guy, and we have this distance value. What's the value looks like? Let's debug it. Debug drawer. We actually need a debug loop. Back to this view and then have a look. It's not giving anything because we need to turn this on. So the value is like that. We definitely can use that to rotate our thingy. So the value is already between 0 and 1. Let's use map range anyway. Map range. Distance value goes in there. And with that output, we can plug in into the rotation. Let's go down. Value goes into the rotation. It will, of course, create this combinular. We don't need to use degree. It's actually in radian rotation. But we can take advantage of the map. So at the moment, it's looking like that. Maybe I forgot something, but the output maybe is more like that. Is clamping? Maybe it shouldn't be on. Vector distance, blah blah, separate vector. Original and displace. Maybe it should be this. Yeah, I think that might be more correct. Probably the output is not too much. Kind of get the idea. Anyway. If we get rid of the matte cap, so clamp input is kind of not clamp input, not that guy. Vector distance, probably that and that. That's probably better. I adjust the rotations here. Kind of trying to emulate the mirror effects. Maybe that's probably better. Yeah, maybe I shouldn't use the RGB value like in the target here, or so it's currently, it has this RGB to XYZ in direction. Maybe it should be normal or custom normal, or just in the Z, just looking like that. Leave it there. X, Y, Z. Maybe it shouldn't be in the X. Should be in the Z. Cut it. Y? No, it's actually in the X. It was correct. I think I forgot something, but anyhow, we get this kind of effects, and then it's almost real time, and don't worry about this, don't worry about that. We can use any kind of geometry actually, like maybe Suzanne should be facing up, so I'll rotate it -90. Suzanne's road. Scale it down, and I'm gonna source it. And apply the material. Okay, so yeah, this can be useful for whatever you're doing, so you don't need to have particles and object instancer. You just need to have set up like this. Take advantage of the Blender Displace Modifier, and it samples the image really fast. So I tried it with 100 by 100 samples. So it means 10,000 objects in the scene. 10,000 objects can be anything, and it was pretty fast. It was under 1 second to calculate. I will not do it here right now, but yeah, it's so if I use random Euler, plug in the index into there, and then plug in the Euler. Again, it like this, it looks pretty complex, and you can scale the value, and then you can also use the wiggle. It's pretty cool, right? File, save. And if I'm not wrong, so far we have been just using the grid mesh. Remember, we have this grid mesh. Let me try if we use like a random vector. Let's see if actually working or not. So random vector. We're gonna generate a random vector. So we're gonna need a loop. Input. How many random vector do we need? We don't know yet. With the random vector, we don't need the z value, so we're gonna separate the vector and combine the vector back like that. Oops. Feel slow. Okay, stop that. Plug it in. And we're gonna pipe it back. Vector release. Plug that in. Okay. And we better name this generate random points. There. How many should we create? Let's try with 40. Actually, that's too many. Okay, 40 is okay. So we have our vector list here. If I plug that in, it might break. Didn't actually break, which is interesting because it's still piping everything into this target object, and our target object is still the same with the displacement still happening, which is really nice. Actually, I didn't try this before, but here you can see how procedural setup can be really powerful. So I decided to kind of have like 1000 Suzanne in the scene, and it's still pretty fast. It's going up. 1000 Suzanne is like 10 by 100. So instead of having this in the grid mesh, we have it in the random, more like a random fashion like that. It's almost like particle and instancing. Let's hide our Suzanne into layer number 2. Okay, so that's pretty much it. that's the result. Looks really complex, but it's actually simple underneath. Yeah, so hopefully you find this live noding session useful. Please subscribe to the BlenderSushi channel for more videos like this. Thank you very much for watching. I'll see you next time. Now let's pause the video. Let's